Our topic explores how machine learning can be used in socioeconomic mapping to help reduce poverty. Poverty affects individuals around the world, and there has never been an efficient and completely accurate way to map out this information. In the history of socioeconomic mapping, nighttime satellite images were used to decide the poverty regions, based on the accessibility to electricity. Door-to-door data collection is impractical and expensive as well, due to the abundant need of manpower and lack of travel resources to more isolated regions. Flaws in both of these methods led to the use of machine learning in socioeconomic mapping to create a more accurate representation of socioeconomic status worldwide. Socioeconomic mapping is important because it can help with targeted disaster relief, sustainable development, and targeted poverty reduction plans.
Machine learning is generally defined as an aspect of computer science that uses statistical algorithms to give computers the ability to learn given data without being explicitly programmed. The following are machine learning techniques that are used in socioeconomic mapping. Transfer learning takes one or more source tasks and uses it to improve learning in a related target task. It involves asking what data to transfer from the source task to the target task, when to transfer this data, and how to transfer learning from one domain to another to improve performance. Deep learning involves data represented in a hierarchy. One type of deep learning is convolution neural networks. This type of deep learning takes data and orders it so that the output to one layer is the input to the next layer. It can be used with transfer learning by taking the first few layers, which usually represent borders and edges, and using them as a source domain to get high-level features, which are the target domain. Clustering involves grouping data based on certain characteristics. When used with transfer learning, one clustered data serves as the source task, and it is used to then sort the target task. This transfer learning algorithm uses three distinct steps to produce a socioeconomic map. First, the algorithm uses deep learning techniques to train a CNN model to identify low and mid-level map features using the ImageNet database, which is a collection of images that is designed to be used for visual recognition training. Next, the algorithm trains the established CNN to predict nightlight levels based on the daytime satellite imagery. The algorithm uses nightlight as a proxy for economic stats. Finally, the algorithm uses clustering techniques to create a regression model that will predict economic status of the lowest level feature identified, which is most frequently villages. In some cases, World Bank data on household assets can also be integrated. Machine learning algorithms have vastly improved the accuracy of socioeconomic maps. These more accurate socioeconomic maps mean that targeted poverty and disaster relief and sustainable development can be designed and implemented for greater impact on impoverished communities, which will hopefully improve the standard of living for many people worldwide.